Hello friends, in this lecture we are going to learn about another STL member, that is list. List is basically kind of a linked list where what we do in, again, STL provides you with the class list, and in a list you can push back elements. Okay, you can push element in the front, you can insert element in the middle like a linked list, you can iterate through the linked list, access its elements, and then delete some elements from the linked list, and so on. Okay, the good thing about list is the plus points. You can basically delete any element, okay, and you can insert at any point in the list, okay, without much of complexity in comparison to vector. Okay, but the thing that vector has is that you can access any element just by writing its index I, because vectors are stored in contiguous memory locations. In list, what happens, the elements are not stored contiguously, so whenever you need to access the ith element, you need to traverse the first, second, third till the ith element and then access it. But the deletion is very simple, because if, let's say, this is the linked list and we want to delete this item, we just point this element here, so this will be removed. Okay, so this is the case insertion also. If I want to insert something here, just point this one here, it's next to this one. So in list, this is the benefit, and it's dynamic. Okay, you can add memories, it's more efficient even in terms of memory allocation, because vector, if you need to make it dynamic, so we will allocate some space, and then if you are increasing from that initial capacity, then because the memory needs to be contiguous, and if that memory is not available here, whole array now needs to find a new place where everything can be stored contiguously. So this is about the list and vectors, but let's see how we write a code for list. So very simple 101 code for this is hash include list, that is the class. So hash include our list class using namespace standard, so you don't need to write always as standard list. Okay, so this namespace I already provide the compiler that I will be using this namespace standard. So list, when I want to define a list of integers, I will just write list, what type of list, what items should it contain, what data type, int, and then my list is L. Now I want to do a push back, okay, where I will push the items in the end. So L dot push back your item, so 0. L dot push front also 0. Okay, so that's fine. So we will push in the front also 0. So but what happens, push back means this is the start. So let's say there was 1. So now your list is something, start here, this is the end, 1 is there. Push back again, let's say I do a 2. So push back will be at the back, so 2 will come here. Push back 3, so 1, 2 and 3 will come here. But if you do a push at front, so what will happen if 4 is at the front, so push front will have 4, 1, 2 and 3. Okay, so this is the case. And now what happens, L dot insert, if I want to insert somewhere in between, so I will do L dot begin is the starting pointer, and then I will give 2, so I want to insert somewhere in at the second place. Okay, so somewhere here. Then what I want to do, I want to iterate through the whole list. So I will have again, so one important point, I will have a iterator. How you write the iterator for list? I will first write what kind of iterator I want that for a list. So list int, then an iterator for it. So iterator I will write, and then I will point it to the beginning. I is L dot begin, which means it will be pointing here. Whenever you do I plus plus I, it will means this pointer iterator will move here, then again here, and so on till it finds the L dot end, which is the end of this. Okay, So it will move there. You can access the element by using *I, the value stored at the iterator that place. Okay, this is the simple code. Now let's try to run this. So we will put some good values here. Okay, the next element, let's say it's 10. I build this code. So it's working fine, and now let's try to run this. So list was there. We inserted 0 initially. Then that was push back. Then we did a push in front, and that was 10. So 10 came, so 0, and before that 10. So 10 0 was there. Now what happens? So let's see. So let's try to analyze this thing. Initially I did push back 0, 0 was there. Then push in front 10, 10 came here. This, then insert plus plus L dot begin. So L dot begin is here. I came here at this point, and then you inserted a 2. So 2 will be inserted on the left. So 10 2 0. Then you did push back 5 and then push back 6. So wherever is your iterator, if you push at that point, insert at that point, just before that it will be inserted. So we saw that 0, then 10 was there. We did plus plus L begin. So this was L begin. So it came here, and then we inserted 2, which was just at left of your iterator. Now your pointer basically. So now iterator, we iterate through begin to end, and we print out the value. So this is what you get, 10 2 0 5 6. So this is good enough for beginning about iterators. If you want to know, let's move further and little bit see a few more code. Okay, so little bit about deleting some elements. Okay, so let's put some new code here, and we would like to see. So we will have some erasing from a list, some items. Okay, so we have my list. Okay, so we construct a list which is of type integers, data type. My list is its name. I have two iterators, one is it1 and another is it2. So what I do, just make a for loop. I'll do my list dot push back multiples of 10. So 0, it will be 10 20 30. So till 100 I will push the items. In fact, is it 100 or just 90, less than 10? Okay, so that's what is entered. So you will have elements, let's take, so it will be pushing everything 10 20 30 40 50 60 70 80 90. So these elements are inserted in your list because it was of type list of type int, and then I define my list. Okay, so this simply says that your list is of type data type int, it can store. Then I have, what I have is, let's say, two iterators also I define, which means I can iterate through, I can point to some elements using the iterator it1 and it2. So it1 and it2 both I define equal to, make it equal to my list dot begin. So this is my list. Okay, so this is the list, and what I do is that I point both it1 and it2 to the beginning. So here they come. Let's put it in different color. So this is it1 and it2. Now what I do, advance is an algorithmic function that is provided it2, 6. If you advance it, it will go to some location to +6. So it2 1 2 3 4 5 and 6. it2 comes here, and it is not here after this line, and plus plus it1. So it1 will also go and it will come here. So it1 comes here. Then what we do, it1 is equal to my list dot erase it1. So now see the importance of this line. I want to erase something, and what is that element? I am pointing it1 at the element 20, which is at the second element. I delete it, and then why I am writing this line. So what happens is I delete this element, this one goes, and now my pointer is pointing to, basically 20 is deleted, and my it1 will now point to this element. Okay, so this is how STL works. So it will point to the next element that has come to the second place. Okay, so IT2 was initially at the second element. Now because 20 is deleted, 30 becomes the second element. IT2 is pointing to that element. So let's little bit delete few things so that it becomes easier for you to understand. Okay, so now what happens is that IT2 is here. This is IT1, in fact IT1, yeah, IT2 mylist.erase IT2. So IT2 is done. So if you remove this, so 70 will be gone and IT2 will now point to something 80, IT2. So this is now IT2 is pointing to 80. Then I do plus plus IT1. IT1 will come here and your minus minus IT2. So IT2 will come to this place. Now we do mylist.erase IT1 comma IT2. So you can provide some range also for erasing, that erase between these two, whatever is there. So what happens if you do like this, your erase is that it will erase from the first one inclusive and just before the second one. So these two elements will go and your IT1 so will come here, okay, to the 60th element, the element 60. So let's try to see. So they will come now, both of them will be at the element 60. Then we just print them out. So my IT1 is mylist.begin, IT1 is till it's not equal to mylist.end. We just increment it and print that out. So let's try to build this one and see what happens. So if we build this, my list contains finally 10, 30, 60, 80 and 90. So this is what is there. In fact, we should try to have this after each one of them so that we can appreciate this much more. Okay, so one here, this is just for printing. In fact, you could write a function for it, but just printing it now. I write it here, again I delete here. If you write like this and again there is a print statement here. So build, what has happened, I have not taken this one out. I build this code, I think it should work fine. So let's try to see. Initially all the elements are there. First delete was of 20, next delete was of the element 70, and then what happened was that 40 and 50 goes, 10, 80 and 90 is only left. So where is that one? So IT1 to IT2. So what happened is that only 60, 80, 90 are left. So that's there. So 60, 80 and 90 are left after the delete. So this is the case. Okay, so next thing is we will